This video is the review guide for congruent triangles, which is our unit 6. So we're going to go ahead and start with question number 1. If I take a look at question number 1, it says in the following diagram, it is known that ABC and FE bisects AC at B. So when you see this sentence, then it wants to know what could be concluded based on the given information. But I want to kind of highlight the word given here. So it's telling you that all the information above are givens. And even if it doesn't use the phrase given, you need to know that. You need to know that when I write something in a sentence, it's still giving you really valuable information. And so much gets lost in the words because we think there's not important facts in there. So when you see a sentence such as this, I want you to highlight each piece that they're giving you and mark your diagram accordingly. So it says in the following diagram, it is known that ABC. So I say that ABC, but that's really saying that ABC is a straight line. I know it doesn't seem important, but it is really important to know that this is a straight line. Straight lines give us linear pairs, they give us vertical angles, and if I don't know that it's straight, I don't know that those things exist. But I will acknowledge that that is not something that you want to mark on your diagram, so I'll just put a check mark as in it's good to know and I'm going to keep it in mind. The next thing I need to know is that EF bisects AC at B. Now this is really, really vital information. If you've been keeping up with me in class, you know that every time I see the word bisects, I often circle it because I need to remember that bisect means to cut in half. And when you try to think about what you're cutting in half, it's always what's coming after the word bisect. So that line segment AC is getting cut in half. So remember, the line segment AC is right here, and it's saying it's getting cut in half at B, which means B is my midpoint, and I have these two congruent segments, one on each side. So really important information I got from that given. Now it wants to know what can be concluded based on this given, and the markings say it all. I now know that AB is congruent to BC. So let's go ahead and write that. AB is congruent to BC. Now, this doesn't ask us to explain, it just asks us to conclude. So right now, this is your answer. But because this is a review guide, I am going to provide you with an explanation because very easily on a test or a quiz or any kind of assessment, you can be asked to explain how you know that. So in an explanation, you're just thinking about your given, a bisector, and what your next statement and reason would be. So AB being congruent to BC would be your next statement, and the reason is a bisector divides a line segment into two congruent halves. Right? So now I have number 1 done, and it really taught us that we really need to focus on those words that could get caught in the mix or lost in the mix, I guess I should say. So now let's take a look at number 2. Number 2 says, which of the following is the correct reasoning for why angle ABC is congruent to angle DBE? Okay, so it's really important that we identify where those angles are. So angle ABC is right here. So I just want to make note really quickly, since we're still having trouble with our angles, that that middle letter tells us where the actual vertex of the angle is. So when I'm going from A to B to C, I know that the real angle is right here at B. And from D to B to E, the real angle is right here at B. So those are congruent angles. And notice it's two straight lines that give us those angles, so those are vertical angles, okay? The question is asking for which of the following is a correct reasoning, okay? A lot of us are gonna look at number 1 and be like, oh, vertical angles are congruent, that's great. But let's keep reading and see what else are our options here. So for number 2, it says perpendicular lines create right angles. This talks nothing about perpendicular lines, so I think it's safe to say that 2 is not our answer. Number 3 says intersecting lines form congruent vertical angles. Tough contender with number 1, so let's keep that in the mix too. Number 4 says midpoints divide a segment into two congruent parts. True, but not given here. Nothing important Nothing about midpoints is talked about in this example. So I'm between 1 and 3. And 1 is meant to be a distractor because 1 will actually not receive credit on an assessment. Because not all vertical angles are congruent, it needs to be vertical angles formed from intersecting lines. So number 3 is our correct answer. But number 1 is our most misleading wrong answer. So it just goes to show that you really still need to read all of your choices, even if you're confident in the first one, just so you can make sure that you're not being tricked. All right, example number 3. Example number 3 says, in which of the following diagrams is there not enough information shown to prove the triangle is congruent? So this is really important because oftentimes this gets caught up and forgotten that it says not enough. And that's really important because the first one you're going to see, for example, this first example, is enough information, and you might get all excited and circle that. So let's talk about why it is enough information. If I go ahead and I cover, so I always tell everyone that you should cover one of the triangles. So if I, let's say, scribble on this side and cover this triangle up so I can't see it, right? I can still see this triangle ABC, and I see that I have one side and one right angle. That is not enough information to prove two triangles congruent, a side and an angle. So if I go ahead and take a look at this, I might notice that the diagram gives me something. CB is shared in both of those two triangles. So that means that CB is congruent to CB via the reflexive property. And if I took a look at this again, and again, if I covered up one of those triangles, I might see that this feels like angle side side, which we know is a bad word. We can't use this in a proof. This is absolutely not, right? But if you find you get angle side side, think, is it possible that it's HL? And in this case, it is. And remember, for HL to work, you need a right triangle. Or you need two right triangles, I guess I should say. So here I have a right triangle, I have a hypotenuse, and I have a leg through the reflexive property. So this is HL, which means these can be proven congruent, which means it is not my answer. Let's move on to number 2. Number 2, same thing. I see that I can use the reflexive property here. And I also see that I have angles and sides. So if I take a look at this guy, the difference is, remember, you can always cover up one of the triangles. I believe that this is also angle side side, which I cannot use. So then you have to think to yourself, all right, if I can't use angle side side, is it HL? And the answer is no. And why not? Because this is not a right triangle. So I think that this may be my answer. I think that this may not be enough information. But like I said in this example, let's check the others just to make sure. Example number 3, everything's marked really nicely here. And I believe this is a very good example of side angle side. So I'm going to say this can be proven. So this is not my right answer. And last but not least, again, I have that reflexive property. And I just want to strongly encourage you again. Let me see if I can make this covered up. It's always hard on here, but I'll give it a shot. Yeah, it's not really covered up, right? But if I cover up one of the triangles, I know you can still see it fairly well. The other one will show me that I have angle side angle. So let's get rid of this guy. And since this is angle side angle, I know that this is not my correct answer. So still, even after going through all my choices, I thought it was number 2, but now that I've seen that the other ones definitely won't work, now I'm positive number 2 is the correct answer because it requires angle side side, which is not appropriate for proving two triangles are congruent. All right, example number 4. Given that triangle ABC is congruent to DEF, which of the following statements must be true? So for this example, this isn't a not example. It wants to know which one must be true. Now, what's really important to recognize about number 4 is that you don't see triangles. They didn't draw these triangles out for you. And I got to tell you, when I look through multiple choice questions on Regencies, on tests, on quizzes, if you have no work for this example, you get it wrong 99% of the time. So what we're going to do is if they talk about two triangles, especially two congruent triangles, we are going to draw those triangles. And we are going to remember that we need to line up the corresponding letters. So I'm going to go ahead and erase everything I just highlighted because I want to make sure I'm doing this color-coded. So first things first, I'm going to draw two triangles. You do not need to be an artist. You just need two triangles that look fairly similar. Okay? Then I'm going to recognize that A is the first letter in this triangle and D is the first letter in this triangle. So let me tell you, it does not matter where you put letter A. I'm going to choose to put it up top. But wherever you choose to put letter A, letter D better be in the same spot in the second triangle. Same thing over here. I have B and E are in the same position. It does not matter where I put B, but wherever I choose to put B, so in this case on the bottom right, I need to do that same thing in my second triangle. Now let's take a look at our last letter, which was F. I'm going to try to do this C and F. And let's see if I have the right color. I do. So this would be C and this would be F. So everything's nice and color-coded. I'm going to go ahead and erase inside these triangles just so it doesn't look too confusing. And now I'm going to decide which of these statements on the right are true. So my first one is saying that angle A is congruent to angle E. Well, let's think about it. Angle A is up here, and I can already tell from my color coding it's congruent to angle D, not that angle E down here. This angle E is off in a different color in a different position. So I can tell you right away that statement 1 is false. Okay? Then it's saying BC is congruent to EF. So now I'm taking a look at the second given, sorry. BC is congruent to EF. Well, BC is right here, and EF is in that same position, so I would say that that is 100% true. BC is congruent to EF because we know corresponding parts of congruent triangles are congruent. So since we know these two triangles are congruent, we know all their corresponding pieces are congruent. And I'm just going to write that out because we should really be practicing that sentence. So corresponding parts just stands for like sides, angles, of congruent triangles are congruent. And this is an important thing to recognize, understand, memorize, because remember, C, P, C, T, C. So you can always abbreviate this using C, P, C, T, C. And that's the reason why number 2 is correct. So keeping that in mind, if I go on to statement number 3, it's talking about angle ABC, which is this guy down here. Remember, since B is my middle letter, that's where I'm focusing. And DFE. And DFE is over here. So that is not in the same spot. Here, my angle is focused on this green letter B. And here, my letter is focused on this purple letter F, which means that ABC is not the same as DFE. So this is incorrect. So now looking at my answer choices, I see that only 2 is correct. So I can go ahead and circle that. And I feel very confident. And again, think about this as from a teacher's perspective. If I go back to this multiple choice, look at all this good work I should see, right? And I'm going to go ahead and erase this angle marker because I don't want you guys to think that that's true. All right, example number 5. So this is another situation where I don't see any numbers. I see a lot of words. Luckily, they gave me a diagram, but I should be highlighting as I go, highlighting given information, and making sure I mark it off in my diagram. So in the diagram below, it is known that BD bisects angle A. Let me get a bigger highlighter here. BD bisects angle A. And let's mark that. Let's go one at a time, right? So BD bisects angle A. So again, I see that word bisect, and now I'm looking at what's being cut in half, angle ABC. So if I look at that here, angle ABC. So keep in mind again, guys, that B's in the middle. That means this full angle here is being cut in half. So how would I mark that? I'd mark that by having I'm just going to erase the highlighting now that we see it, a congruency marking here and here because it was broken in half by BD into two congruent angles. So now I've marked it as being bisected. Okay, next, my next given is that AD is perpendicular, let me change my highlighter again, sorry. AD is perpendicular to BA, so let's go ahead and mark that. We know perpendicular lines give us right angles, so if I take a look at this, I have AD and BA, which means that those two line segments make a right angle right here. And then I'm going to go ahead and mark the next one, the next given, BC is perpendicular to CD in the same color because it's the same type of given. And now it's telling me that BC, this guy down here, is perpendicular to DC. So that means that I have a right angle here as well. All right, then I'm going to keep on reading. It says, which theorem could be used to prove that DAB is congruent, triangle DAB is congruent to triangle DCB. So the two triangles that I see. So I marked everything that I can. And now I'm looking at this, I'm a little confused because I do know that I only have two pieces to a method. So again, I'm going to go ahead and scribble one of these out. Let me make it a really, oh, I think that's as thick as I can go. So I'm going to scribble one of these out and I see that I only have two angles. So that's not enough information. But in looking at this diagram, I should recognize that the diagram gives me a given. It gives me the reflexive property. So now if I go ahead and cover up one of those triangles, I'm not going to do it for you now, you should see that these two triangles can be proven congruent by angle, angle, side. So that is my method here, angle, angle, side. And it's just asking for the method, so you can say angle, angle, side. If you wrote angle, angle, side is congruent to angle, angle, side, that's fine as well. Okay, moving right along to question number 6. It says, in the diagram below, and again, this is given information, we need to be careful. TR is perpendicular to RS, and let's go ahead and find that. So TR is right here, RS is right here, which means that this is my right angle. I'm going to keep on reading. I'm going to make it the same color since it's the same type of given. And TW is perpendicular to RS. So here I have TW, and I also have WS. So I know that my right angle is right here. Then if I continue reading, it says TR is congruent to TW. So I have TR and I have TW. What postulate would be used to show that triangle TRS is congruent to TWS? Now again, once again, I can use the reflexive property. So this is another interesting case, kind of like that multiple choice. If I was to read this, first of all, I'm just going to talk about how to read methods because some of us still have trouble. It's important to recognize that this pink marking is in the middle. Okay, so either way, when I read this, if I start with the blue marking, I can identify it as angle, side, side, right? If I go with the colors, which is a bad word. Or if I go the other way, I can think of it as side, side, angle, which is just a bad word backwards. So right now, my first instinct is that I cannot prove these two triangles congruent because it does not give me appropriate method. But remember, this is a very important fact, a great thing to write in your things to remember. When it gives me a bad word, I need to think to myself, well, I know it won't work with angles inside, so is this a hypotenuse leg in hiding? And the way that you know if it's a hypotenuse leg in hiding, remember, what is the only type of triangle that has a hypotenuse and a leg? So you really need to ask yourself, is it a right triangle? And let's think about it. Is this a right triangle? Yeah, it has a right angle. It's a right triangle. So let's think about this again. When I think about where the hypotenuse is, let me change the color. The hypotenuse is across from the right angle. So this is a hypotenuse. The leg is next to the right angle. So this here is a leg. So this is hypotenuse leg. So which method would prove these are congruent? Hypotenuse leg. Okay, a little tricky, but just remember, if you spell a bad word, think about if it could be HL. All right, example number 7 is one of my favorites. So again, I'm going to read through it. I'm going to think about the givens, and I'm just going to take them one by one. So example number 7 says, in the diagram below of triangle ACD. Now remember, ACD being a triangle may seem insignificant, but it gives us this as a straight line, which is really, really important because it's telling me that these two are linear angles. Are linear pairs, which means that they're supplementary, or I can add them to equal to 180. So it is really important that they give me that given, but I do acknowledge that that's not really something you want to mark because it'll make your diagram messy. So I'm just going to go ahead, check it off. It's there. I love it. And I'm going to leave my diagram the way it is. Helpful, just not something I want to mark. Then I'm going to take a look at my next given, which is that DB is the median to AC. Now, there's a couple of really important words here. Remember, median, I need to know that a median goes to a midpoint, and then a midpoint gives me two congruent halves. Now, again, this is all really key to the word that comes, or the piece that comes after median. And in this case, it's AC. So AC isn't the median, DB is the median, right? They told me that DB is the median over here, but it's important because what's getting the midpoint? AC is getting the midpoint. What's getting the two congruent halves? AC is getting the two congruent halves. So this AC is really the star of the show. So always, always, always the word that comes after, the piece that comes after the key word is really what's important. So in this case, if I take a look at AC, right, I know that that is what the median's being drawn to, which means that B is my midpoint, and this line segment is congruent to this line segment because those are my two congruent halves. I'm going to go ahead and take this highlighting out just so I make sure that I don't make it too messy, but hopefully you're able to follow along with that. The next given that they give me is that AB is congruent to DB. Now this is really important because when you go to mark AB, you should kind of stop in your tracks because if you notice, AB already has a marking there. So that means when you go to mark DB, you should put the same marking. I know that can be a little confusing because we're used to putting the 2, but if AB already has the 1, you just need DB to match it, which means all of those line segments, AB, BC, and DB are all the same length. Let me show you that again. AB, BC, and BD are all the same length. Now, I'm going to go ahead and keep on reading because it says if the measure of angle CDB is 54 degrees, so I'm going to go ahead and put CDB, remember D is in the middle, CDB 54 degrees. What is the measure of angle DAB? So I'm going to go ahead and be really honest with you guys here. First of all, I'm out of highlighted colors. Let me see if I can find a pretty one. Let's do yellowish, I think. Let's do yellowish. Okay. So it is important to know that I want the measure of angle DAB, but I don't want to get there too quickly. It's all the way over here, and if I try to stress out about how to get there, I'm going to miss so many things. All right. So I want to acknowledge a couple of things. I want to acknowledge that this is a very, very scary diagram. Okay. It's really intense. There's a lot going on. So after I acknowledge that, I want to acknowledge that it's also two triangles put together to make a bigger triangle. So what I recommend, and I know I keep trying to make these blockers and they get like ugly and uglier as I go, but I'm going to try one more time. So if I make this fancy rectangle, let me color it in. As I'm coloring it in, just acknowledge that I'm going to cover the part of the diagram which feels unimportant right now. I don't want to look at it all at once. That would be too scary. So what I'm going to do is I'm going to look at the triangle that has the most information in it, and I'm going to start there and then work from there. So I see that that one triangle has that one measure of 54 degrees. Let's see if my blocker works. Let's see. I'm going to resize. I'm going to put it over here. I think I can make this work. And I'm going to cover that other triangle, right? So I only see the guy down there with the 54. This is much easier to work with. And hopefully when you look at this triangle, you recognize that it has two congruent sides, right? It has this piece over here. Oh, too big. This piece over here, and it has this piece over here. And congruent sides, you can turn into arrows because they point to congruent angles. So over here, I have 54 degrees, and over here, I have another congruent angle. And that's really important because now I know that this angle here is also 54 degrees. And that's a big deal. So now I know that the angles in a triangle add up to 180 degrees. So if I think about this, all right, I have 54 and I have 54 already. If I add those, I have 108. Well, I know a triangle is supposed to add to 180 degrees. And let me restate that because I always yell at everyone when they say it. It's not a triangle that adds to 180. It's the three interior angles of a triangle that add to 180. So if I already have 108 degrees and I subtract that from 180, I'm left with 72, which means this angle here has to be 72 degrees. Okay, and that's really important. So now I got two extra angles, and I think I have everything I can get from this triangle. Now that I feel like I have everything I can get from this triangle, I feel confident. Oh, of course, I knew that was going to happen. I feel confident moving this distractor piece that I put here to kind of get rid of things that I felt might be distracting. So I'm going to go ahead. I'm going to use this again in a few minutes, but I'm going to put that over there. Now I'm ready to look at the bigger piece. So I need some information about this other triangle that's still blank. You should probably be looking in two places. The first place you should be looking is probably over here. And you need to say, can I get that angle? But really you can't. You don't know any relationship between that 54 and that angle you're looking for. And there's just no way to get from here to here. Be careful. Don't assume things. If it's not given to you, you don't know it. But down here, you can actually get the angle next to that 72. And this given over here is the one that's going to help you do it. Remember we said that that was a triangle, so that's a straight line. So you should know that these two angles right here have to add to 180 degrees. So let's go ahead and think about that. If I have 180 degrees on a straight line, and I already have 72 degrees, how many degrees are left? And you should have gotten 108. So 108 degrees is going, this is helping me to find this angle here. 108 degrees goes here. All right. And I'm sorry, in moving that triangle, it looks like I got rid of my other congruent line that we had marked earlier, which was right here. I apologize. So I'm going to leave that there. Okay. So now I have as much as I can get in that little, the other blanker triangle. So I'm going to go ahead and I'm going to take this box, I'm going to resize it, I'm going to make it big again, and I'm going to use it over here. Okay, I'm going to cover that original triangle because it's not helpful anymore. I can't get anything more from it. So I'm just going to pretend like that other triangle isn't there. I understand that you guys don't have an iPad, right? So on a test or on a quiz, you're going to take your hand and cover the part of the diagram that's confusing. You're going to rip out your reference sheet or your scrap graph paper, and you're going to use that paper to cover it, okay? But if I look at this triangle here, I notice that I have two congruent sides again. So this side here, I know the arrow isn't as helpful when it's obtuse, but what you need to think about is on this side, what is the one angle that doesn't touch this side of the triangle? It's this guy over here, okay? So that angle is going to be congruent too. And again, I have this green side here. What's the one angle that doesn't touch that green side? And it's going to be this angle over here, okay? Because in a triangle, congruent sides are opposite congruent angles. So looking at this triangle, and I'm just realizing it's a lot of highlighting, so I'm just going to take some of this out so it's a little less messy for you guys. In this triangle, I have two congruent angles. So we know that all the angles of a triangle have to add to 180 still, right? If I take out that 108 degrees that I already have, let's think about what's left over. And you should get 72. So that means I have 72 degrees to split between these two angles, and they're supposed to be the same measure. So if I take 72 and divide it by 2, I get 36 degrees, which means this guy here is 36 degrees, and this guy here is 36 degrees, right? So that's it. I can't get any more information. I'm going to go ahead and take this blockade out. Of course, now it's going to be a mess, but I think it was worth it. I think it was helpful while it lasted. And now I can just kind of erase it. Let me see if it'll let me zoom out. So now I have all of these pieces, right, to this triangle. And now I just have to think about what they want. And what they want is angle DAB, which is right here, right? DAB. So that means that the measure of angle DAB equals 36 degrees. It's a lot of work, and it's just a nice reminder that something that seems simple may not be. I think this is the hardest question on the review sheet, and it looks just as difficult as the others, meaning it doesn't look any harder, but I think it's the most challenging. It's the one you really need to take your time with and go piece by piece. So love number 7. Okay, example number 8. It says triangle ABC is congruent to triangle FDE. So there's 2 things that I want you guys to think about here. The first thing I want you to do is, before I even read any more of this problem, I'm going to color code. A and F are my first letters here, so A and F are the same measure. B and D are the same, in the same position, so the same color, so B and D are congruent here. And last but not least, I have C and I have E, so it would be C and E. So when we talk about what rigid motion would map, let's just talk about the general rigid motions. So when I say rigid motion, I mean that it's going to be a rotation, which is a spin, a reflection, or a translation. And remember, if it is a reflection, you need to state the line of reflection. If it is a reflection, I'm on the wrong one here. Let me put it down here. You need to state the line of reflection. That's how you completely describe a reflection. If it's a translation, you need to give the rule. So up how many, down how many, left how many, right how many, right? If it's a rotation, we need 2 things. We need the center and we need the degree. So we need to make sure that we're completely describing whichever transformation we're using. So here you have to think about it, right? Was it a flip? Was it a spin? Was it a slide? And this was because it's asking me what rigid motion would map ABC onto FDE. And I believe this will be a reflection. So on a test, on a quiz, I'd probably make it a little bit easier to define the line. Let's go ahead and do it since this is what we're given. This should be a reflection. And I need to say what line it would be over. So if you're looking over here, I think you can all easily identify where the line of reflection should be. But we need to be able to describe that line. So I think we can agree that it's going to be equidistant to the 2 triangles. And if I was to draw a line from B to D, I think we can agree that it would be perpendicular. So I'm going to call this over the perpendicular bisector of BD. So since this is the perpendicular bisector, right, obviously a right angle there, that would be the line. It's a lot easier when the triangles are touching and you can just name the side that it flips over, but we're working with what we were given. Then B is saying determine the measure of angle CAB. So they want us to find, so let's see, CAB is right here, CAB, this angle here. Okay, I know nothing about triangle ABC. There's just nothing there. It's completely blank. But I do know something about this bottom triangle. It's giving me 3 different angle measures. And I do know that all the angles in a triangle do add up to 180 degrees. So I can use this triangle to make an equation. I can say that 5x plus 3x plus 2x, let's move this over so it doesn't interfere with my arrow, equals 180 degrees. And if I go ahead and add those together, 5 plus 3 is 8, plus 2 is 10. So now I have 10x equals 180, right? So if I divide by 10 on both sides, I end up with x equals 18. Okay, so remember, that's just x, that's not an actual angle. So I'm gonna need to go ahead and plug it into each of the angles in that triangle to make sure that I'm finding their measure correctly. So if x equals 18, what is this guy? Well, this guy would be 5 times 18. So 5 times 18 is 90, which means that this equals 90, or this angle is 90 degrees. Okay, over here, we have 3 times 18. So since 3 times 18 is 54, I know that this degree measure is 54 degrees. And over here, we're going to have 2 times 18, and I know 2 times 18 is 36. So this is going to be 36 degrees. And if I really wanted to, I can go ahead and add all those together real quick just to make sure they add to 180, which they will. Now let's go back to what they wanted. They wanted this angle up here, which is very clearly angle A. So they want to know what the measure of angle A is. Angle A matches with angle F. So that means that this angle here is corresponding to angle A, and it's going to give me the same measure. You can also notice that there's 2 markings on angle A, these 2 little lines here, right? And there's also those same markings on F. So either way, the measure of angle CAB is going to be the same as the measure of angle F down there. So just to bring the point home, guys, this is going to be 36 degrees because A matches with F. This is going to be 90 degrees because B matches with D. And because C matches with E, this is going to be 54 degrees. So that means the answer to that question, what is the measure of angle CAB? Our answer is 36 degrees. Okay, moving right along. So a couple of things about these fill-in-the-blank proofs. We cannot control how they write their proof, right? When we write our proof, we can do it in the way that's most comfortable for us. When it's given to us in this way, we really can't. So we have to take what they're giving us, take what we know, and bring it all together. So let's start given by given. So I still recommend that you take one given and go with it, right? So for example, this first given, HF bisects angle E, right? This is really important. We also see it down here. It was given to us, right? In the given statement. This person who writes their proofs likes to write all their givens at once. That's why there's more than one line in statement 1. We're still going to take them one by one. So think about this, guys. The word bisects, HF bisects angle EHG. So angle EHG is right here, which means this angle is what's cut in half. So that means that I can mark that with this angle being congruent to this angle. But what comes after a bisector, right? So if I take a look at statement 2, it has EHF is congruent to GHF, which means it has this angle here congruent to this angle here. What's the reason for that? So let's write out our reason. An angle bisector divides an angle into 2 congruent halves. Okay, so we filled in our reason for that statement. Done. Let's go on to our next given. Our next given has angle HEF is congruent to HGF. That is also written here. And if I look at that, HEF, HGF, that, well, let me do 2 because that's our second angle. But that is a one and done given, right? So that is not going to give me any new information. So this provided me with an angle right away, and this one down here that I did before also provided me with an angle. Now we'll see step 3, says reflexive postulate. Now in class, we always say reflexive property. Don't be thrown off by that. They're allowed to say postulate if they want to, and you just need to recognize it. It's the same thing. What are those 2 triangles sharing? This side. So here, what is congruent? Let me just get it closer, sorry. FH is congruent to FH because of the reflexive property, which they called postulate. Totally fine. That is my side. Remember, when I write my A's and S's on the side over here, this is not to indicate the method. This is just to show me I have everything I need to prove something. So we're going to go to the triangles and decide on the method, which I think you would agree would be angle. So angle, angle, side. And I can state that triangle EHF is congruent to triangle GHF because angle, angle, side is congruent to angle, angle, side. Okay? Beautiful. Let's move right along to number 10. Number 10 says the coordinates at endpoints of QS are Q, negative 9, 8, and S, 9, negative 4. Point R is on QS such that QR to RS is in the ratio of 1 to 2. What are the coordinates of point R? So this is partitioning a line segment. This is a review question from way back when, but hopefully we remember how to do it. It's an important one. It shows up all the time. Okay, so first things first, if I take a look at my ratio, it's telling me I want one piece on one side, two on the other, which means there's 3 pieces total. So when I go ahead and draw my little graphic organizer, I'm going to be drawing so that there's 3 pieces to my line segment. Okay, so that means, let me erase that one more time and redo it. So that means that if I start here, guys, one piece is connecting 2 points like that. That's one piece. I'm thinking of the segment, not the points. Okay, this is 2 pieces, and this would be 3 pieces. Okay, so I have my 3 pieces. Again, it's a drawing. It doesn't need to be perfectly accurate, right? And I know that my first point is going to be Q, which was negative 9, 8. And my last point is going to be S, which is 9, negative 4. Now, those 2 points in between represent actual points. And what I want you to do before we go any further is I want you to think about which point is going to be my answer. So, for example, if I was to put my arrow down here, this would be split up in a 2 to 1 ratio, which is not what I wanted. I wanted 1 to 2, right? So I would have to move this arrow up 1. Oops, sorry, I thought I had the wrong tool. I'd have to move this arrow up 1. All of the arrow, please. And now it's split in a 1 to 2 ratio, okay? So that is the correct point that I want for my answer. Now I'm going to go ahead and think about how I move in this situation. So I'm just going to zoom in, and I'm actually going to label this R because it is point R. And I'm going to think about my change in Y and my change in X. My Y is changing from 8 to 4. So that means that my Y is actually going down 12 units. And you can always subtract if you want. You can do 4 minus 8, and it'll give you negative 12. But I don't want to do it in one big jump, right? I want to do it in 1, 2, 3, which is the same as that total I found over here. It always will be. So I'm going to go ahead and divide this 12 by 3, and that's going to give me negative 4. So that means each time I jump, I'm going to jump by subtracting 4. So 8 minus 4 is 4. 4 minus 4 is 0. 0 minus 4 is negative 4. And I know I did a good job because I got to the right number at the end. Remember, this was our change in Y we were working with over here, right? Now on this side, for our change in X, we're looking at what happens when I go from negative 9 to positive 9. And that is going up by 18. And again, I want to divide that 18 by 3. So that means I'm going to be going up 6 each time. So let's see. Negative 9 plus 6 is negative 3. Negative 3 plus 6 is positive 3. 3 plus 6 is 9. So I know I did a good job because I got to the right answer at the end. So that means that partitioned point is going to be this R, which was negative 3, 4. So that is the point which divides the line segment in a ratio of 1 to 3. Okay, so now I am not to the end of my review sheet, but close. I am going to be doing a proof which is not fill in the blank. I am writing it as I want to write it. And I'm going to start with my first given. So my first given, I want to recognize that it is pretty much the same as my second given. They're both giving me perpendicular lines. The only difference is my first one is talking about AB and BE, so it's showing that this here is a right angle. And my second one is showing that CD is perpendicular to CE, showing that this is a right angle. So I feel confident putting both of these givens together because I don't want to write too much and write the same reasons over and over again. We know that perpendicular lines is a 3-step routine, so I don't want to do that twice. So I'm going to put those two givens together because they are the same type of given. So what I mean by that is for number 1, I'm going to say that AB is perpendicular to BE and CD is perpendicular to CE. I'm just going to write them one underneath. You can write them next to each other if you wanted. Those are given. And if you look at your special steps and proofs, or if you just think about this, what do perpendicular lines give you? So let me just write it up here. Perpendicular lines give you right angles, and right angles give you congruent angles. Okay, very important. There's 2 steps that have to come out of this. So that means that statement number 2 is going to be that angle ABE and angle DCE are right angles. And the reason for that is perpendicular lines intersect to form right angles. And remember, you guys are more than welcome to abbreviate words. I just choose not to when I answer keys, so it's clear for those who are struggling. Now I can go ahead and say that angle ABE is congruent to angle DCE, and the reason for that is all right angles are congruent. Okay, so all that work led me to 2 angles that are congruent. So I have one piece of my method and I am done with these given. So done and done. Okay, now I'm going to go to my next given, which is that, highlighter, is that E is the midpoint of BC. So let's write that in. I'm going to do that in pink. So for 4, it's E is the midpoint of BC. That's given. And what does a midpoint give us? So a midpoint gives us 2 congruent halves. And remember, circle the word midpoint and look at what comes after. Where is the midpoint? It's on BC. So if I look at BC, I'm going to highlight something that's already highlighted in a different color. E is the midpoint, which means that E cuts this in half. Okay, so going back to my proof, my next statement is going to be that BE is congruent to EC because a midpoint, I'm going to zoom in to write this, I apologize, a midpoint divides a line segment into 2 congruent halves. Beautiful. So a couple of things here. This has given me a side. So I have another piece of my method. And this given is now done, finished, worked with it. So now what you'll recognize is I used all of my givens, but I still have pieces here that I know aren't enough to prove two triangles congruent. So what I need you to recognize is that I have more in this diagram, and that is this here. This angle is congruent to this angle because these are intersecting lines which form congruent vertical angles. So I can say that those angles are congruent. That's something that the diagram gives you. Vertical angles and the reflexive property you have to see in the diagram. It's not going to be information that's given in a given. So I can go ahead down here and statement number 6. I'm going to say that angle AEB is congruent to angle DEC. And the reason for that, again, I'm going to zoom in just so I can write it correctly. Intersecting lines form congruent vertical angles. And those beautiful vertical angles gave me one more A. Again, over here, this is just to show me that I have 3 pieces, which tells me I can get a method. It's not meant to tell me my method. I meant to look at the triangles for that. So if I go ahead and look at the triangles, I see angle, side, angle, which is going to be the method I'm going to be using. So I can prove those 2 triangles are congruent using angle, side, angle. And I just noticed I put a 7 here. Let me change that to a 6. I always do that. All right, so that means that statement number 7 is going to be triangle ABE is congruent to triangle DCE. And that's because angle, side, angle is congruent to angle, side, angle. So you'll notice they actually didn't want me to prove the triangles, but they're liars. We talk about this all the time. If they don't want you to prove the triangles, still prove the triangles. It's just they now want us to show that since these triangles are congruent, this side AB, which is right here, is congruent to CD. And of course they're congruent because the triangles are congruent. So all the corresponding parts of the triangles are congruent. So we are going to write statement number 8. It is going to be that AB is congruent to CD. And our reason over here is going to be CPCTC. Again, guys, you are allowed to abbreviate that. You do not need to write it out. But if you mix up letters, I have to take off quite a bit of points and maybe not even give you points for that statement or that reason. So just remember that this stands for corresponding parts of congruent triangles are congruent. So you do not need to write both. You can do one or the other, but just try to remember what it stands for. So very clearly, this is your CPCTC. Okay, so that's our proof for number 11. It was a good one. It used perpendicular lines. It used midpoint. It made us use vertical angles. I like that one a lot. Nice 8 steps. Okay, and then we're on, I believe, the last question of our review guide, which is another fill-in-the-blank proof. And it's going ahead and give us some givens here. So I want to point out again, the person who did this fill-in-the-blank proof decided to write all of their givens together over here. So it gave 2 givens on one statement, which is totally fine. It's not how I prefer to do things, but it's okay that they did it. We're still going to look at our givens one by one. And our first given is telling me that triangle WAOK is an isosceles triangle with base WK. So that's this given here. Now remember, it's saying that it's an isosceles triangle, right? And then it's talking about our base. So our base is the only side that's not congruent. So this WK is not one of our congruent sides, which means that I know that WO, let me just make this a little bit bolder for you guys, WO is congruent to OK, which is actually what they gave me right here. Okay, so they gave me the next step in our isosceles triangle routine. So it's just our responsibility to write the reason. So our reason is, let me make this skinnier now, an isosceles triangle has two congruent legs, which you just listed. Okay? And remember, guys, the beautiful thing about an isosceles triangle is those two congruent sides you can turn into arrows. And those arrows are going to point to angles opposite those sides that are congruent. Now, you'll also see that they gave the reason for the next statement. They didn't give the statement. We have to write the statement. So it's those two angles. So typically when I write my proofs, I say in a triangle, congruent sides are opposite congruent angles. What they chose to write here was that if two sides in an isosceles triangle are congruent, then the angles opposite those sides are congruent. So this is more words than I would typically write. I try to abbreviate as much as I can while still being precise in proofs. But that's okay. I still understand what they're saying. They just chose to do it in a wordier way. So the reason, that is the reason for the statement of the two angles which I just stated. So angle OWR, so angle OWR is congruent to angle OKR. Okay? Because this is my isosceles triangle routine, right? An isosceles triangle gives me two congruent sides, and that gives me two congruent angles. Done. Okay? Now I'm going to take a step back, and I'm going to look at my next given. My next given is giving me that I have RO being perpendicular to WK, which means that I have right angles right here. Okay? And remember, perpendicular lines, okay, they lead to right angles, which leads to congruent angles. So let's think about that. Here, they gave my given up here, right? So the next thing I would need to do is talk about them being right angles, and they didn't do that at all. They left statement 4 completely blank for me. So I need to do that. I need to mention that they're right angles. Then I can say they're congruent because all right angles are congruent. So let's talk about what those angles are. It's ORW and ORK. So I'm going to state here angle ORW and angle ORK are right angles. And the reason for that is perpendicular lines intersect to form right angles. Okay? Now that I know that they're right angles, I can clearly state that they're congruent. Angle ORW is congruent to angle ORK because all right angles are congruent. All right? Now I finished my routine there. I haven't been marking angles and sides on the margin like I usually do along the way, but it's kind of really nice because they actually gave me the method this time. And let's see, are they congruent because of angle, angle, side? I think they are. I think they did a good job, right? Angle, angle, side. So all I need to do is state the two triangles, which is what they wanted me to prove. Triangle WOR and KOR. So triangle WOR is congruent to triangle KOR, and that's by angle, angle, side. So this is another fill-in-the-blank proof. This one chose to use isosceles triangles and perpendicular lines. It's really important that you know your routines. A lot of them end up being very similar. A lot of them end up, you kind of commit to memory because you use them so frequently. But perpendicular lines, frequently used. Bisectors, frequently used. Isosceles triangles, frequently used. So just make sure you're looking over your statements and reasons. Make sure you're understanding what you're doing. And more importantly, guys, I just want to say this. Multiple choice questions are often the most difficult questions on the test. Please, when I flip to your multiple choice questions, I should see work. I should see highlighting. I should see diagrams. I should see markings. If it's blank, then it's not a surprise we don't do well on them. Please give them the time and the attention they deserve so that you can make sure that you're doing your very best on the exam. If you have any questions, you know where to find me.